Here we are live. Ray! Happy birthday to us and all the dinosaurs. Happy birthday to us and all the dinosaurs. We are a year old for a podcast deal. Happy birthday to us.
Yes, well, we didn't last 3 episodes and then give up, which is what I think we both suspected might happen.
Well, no, I always knew this would be a winner. This would be the most amazing thing that ever happened ever. And I would know all about things like, pterosaur tips, which is the tip of the wing, which isn't pointy because it would be vortex-like, and you've told me about that, so you know all this already. So thank you very much for watching us. And yeah, it's been an incredible year. We've learnt so much. Dave's learnt loads, I am sure. So there we go. Have you actually? We should talk about this because loads of dinosaur papers have been out in the year that we haven't really covered them on the podcast very much. We covered one of them, like quite extensively.
Mine, yeah. But no one else has researched.
Holtz wrote it. A guy called Holtz wrote it. Is there somebody else attached to that?
And someone else, yes, as you know.
But yeah, so do you want to just sort of like, while we're waiting for our lovely viewers to twiddle us and at us and Facebook and YouTube questions, go. Yes. If you have a question, ask us. In the meantime, hey Dave, what great science have we not discussed this year that Terrible Lizards has been going on?
Well, loads as usual. So I mean, we're still, I think, well on course. As paleontology as a field is still well on course for its 50-ish dinosaurs named a year, both last year and this year. So that's still going on. Though I think it'd be fair to say a lot of them have been pretty fragmentary. I think we're waiting for haven't had a really good specimen in a while, with the obvious exception of the most recent, this really nice hadrosaur from Mexico. And I'm going to murder the name because it's spelled horribly. And I've written it down, Tlahtolophus.
Tlahtolophus, that's a good one.
I think so. Well, it starts TL, which is obviously not the best pronounced yet. Tlahtolophus. And that is the antithesis of what I just moaned about. It's a fantastic specimen, 3/4 plus of the skeleton, really, really good condition with an absolutely gorgeous skull. And the skull is really cool and weird. So it's one of the big crested hadrosaurs with a dirty great crest off the back. Everyone, I think, kind of knows at least somewhat Parasaurolophus with that big like trombone-like extension. Pretty close relative of that, but it's got a flange off the bottom of it. I can see you Googling furiously and hopefully
I'm basically trying to get a picture of Parasaurolophus up because that's
right.
Cool.
Well, I thought you said Tlahtolophus, which is the one we're talking about.
Well, I can't spell it, can I?
That's why I put it in the chat for you. See, some of us prepared.
You're mean. So, have a look at that.
So there's your Parasaurolophus with its big crest. And then this, as I say, this new one from Mexico has this kind of big expansion underneath that. And it's one of those things where it looks really cool, which of course is always nice, but just the fact that it's so well preserved and it's such a good skeleton, is really, really nice. So that's a really nice one. And that was Ramirez Velasco et al. Not a name I know, but that was their team. And then there was the young Diplodocus skin from, again, just a few weeks ago now, really quite recent. So exactly what I just said, a young specimen of Diplodocus found. With quite a lot of skin preserved. We don't have a lot of skin for sauropods, full stop. We don't have a lot of juvenile sauropods. So getting kind of both and a Diplodocus at that, a really familiar taxon. And what was really nice about this one is that not only did it have, quite a lot of skin, but loads and loads of different scale shapes and different sizes, all pretty close to each other in the grand scheme of things. And obviously you expect a certain amount of transition. The back may not be the same as the sides, and things like joints tend to have very small, fine scales in them because it obviously gives you a bit more flexibility. But there's quite a lot of stuff going on with these. And obviously that's really cool for artists and stuff, but also, just really interesting. What does this mean biologically?
I'm just going to do this because I found a picture. There you
Yeah,
go.
there he is.
That was from the previous question. Obviously, we know that they were striped and dotty with a massive crest like that. That is definitely how they were. Everything is science.
Yeah, but as I say, for this one, we have got most of it. So
yeah, that's
okay. Sauropods are fairly consistent in body shape, at least, but still, it's a really nice one. So this was one that hit the news. I want to say 4 or 5 years ago, something like that, because they found the tail, and there was this beautifully complete tail, and there was a photo of it with like 50 vertebrae in a row, just beautifully laid out in a hillside. And they're like, amazing new dinosaur tail in Mexico. And obviously very few people, apart from me, who really likes dinosaur tails, got particularly excited. And of course, what I think none of us realized until fairly recently, but the team did, is when they kept going, there was a lot more interesting stuff than just a tail there. And yeah, that's what they pulled out.
Because it would be an amazing thing to discover, though, that sauropods did drop their tails like newts, and you had the I have that word coming again, phalange. No, not phalange. I get confused between this word and flangipan, which is also really tasty, but it's phalangi. No, Ferengi. No, that's a wrong thing. What's it called? The type of like Diplodocus are flagilli cordata.
Oh, flagilli.
Yes.
Yes.
A year ago, I would never have been able to say flagilli cordata, and now it takes.
I got confused by the finger because I'm like, which
dinosaur has a finger like this?
Yes.
Anyway,
right. Yes.
Yeah.
Diplodocids are.
Yeah.
Yes, but they don't, which is called autototomy, and a bunch of obviously geckos and lizards and other things do this, and it's something that has been suggested for various extinct reptiles. But
I want everybody at home to join me in saying autototomy. Autototomy.
Yes, it's tail dropping basically, or tail shedding.
Everyone, autototomy. Learn it, folks. That's an amazing word. No, it's gone again.
So yeah.
Carry on, Dave. With the
not very good for Scrabble though. Lots of 1 point letters.
That's very annoying for Scrabble. I got Jury in Scrabble the other day. That was good. J and a Y. Anyway, that's nothing to do with dinosaurs. We've had, as we're speaking, loads of people have been sort of writing, and thank you. We're reading them as well as talking about dinosaurs. So thank you so much. And like we've been invited to Florida and Ukraine and to Norwich.
Yes. And someone wanted us to go to New Mexico as well a while ago. We got
possibly. We do actually have a question from further afield if you want to see that. So
try.
It is here we go. So this is from now. I think it's Yao, but I might have got your name wrong. Yes, Barbosa. What can you tell us about Portuguese dinosaurs? Did you ever work on? Oh, see, this is what I should have.
Laringias. I guess. Yes. Yeah, my Spanish pronunciation should be okay. I don't know about Portuguese.
Yeah.
Yeah. So the second half of that is very easy. I'm afraid the answer is no. I've never even been to Iberia. What can I say about Portuguese dinosaurs? Also, not much. Partly because in my mind, which I'm sure will be a great insult to the Portuguese, I kind of conflate Portugal and Spain in my head as like. That's
really bad.
Europe.
That's
I know.
Yeah,
I know. Tough. But in terms of like, I can't necessarily tell you. I mean, I do know that there's some really nice stuff has come out of Portugal, particularly in the last, I want to say 10, 15 years or so. It has quite a lot in common with the UK. So baryonyx and baryonyx-like material, because I think the new Valley-Bonatrix was named from Portugal, so very fragmentary baryonychine, but there are certainly some Cretaceous beds there which are roughly contemporary with the UK, and obviously they're not very far away, and so it's unsurprising that they have similar general faunas but with different species in them, or different genera. Yeah, and there's I think there's tons of sauropods have come out of Laringia, if I'm saying that even vaguely correctly. But I'm afraid that's about all I could say. So I'm kind of out on my Portuguese dinosaur knowledge.
Well, that's I mean, I think you're we've got about the same level, so I can forgive you. Knowledge, so that's fine. That is good. Have we got any other questions? Here we go. We have a question. Where do the toothed birds fit into the picture? Where do they fit into the picture? Birds with teeth. I understand they survived the dinosaur extinction, but where are they now? All the toothed birds. I mean, loads of birds have got the egg tooth to get out the egg, haven't they?
Yeah, and so a whole bunch of them have two different kind of sorts of what you might call pseudo teeth. So if you look at the inside of the mouths of geese, for example, they're very, very sharp. As someone who's been bitten by a penguin, it is extraordinarily nasty.
Sorry, I only just processed that. I've bitten many a penguin, but they're a small chocolate biscuit.
Been bitten by.
What were you doing to that penguin, Dave?
Feeding it. This is when I was a volunteer at Bristol Zoo, and one of my jobs is feeding the penguins, and they're nasty, bitey little things, and they have these vicious serrations on their beaks, and they're full of macerated fish because that's what they eat. And so when they peck you, these lovely serrated beaks don't just draw blood, but leave a really nice ragged wound that bleeds like hell and doesn't heal well, and then fill it with nasty bacterial filled dead fish, which stinks. So you almost inevitably get an infection. So everyone on Twitter who bangs on about how wonderful penguins are, I'm not as much of a fan.
My friend Megan used to work for London Zoo, and she was a part of the events team. She wasn't actually a keeper, but technically outranked the keepers in the hierarchy of things, and so therefore would use this. I think she was joking, really, but she would tell the penguin keeper to hand her a penguin, and then she would hold the penguin and just go, and that's how I think she won at life. Anyway, we have another question popping up here.
We never actually answered that question at all.
Oh, sorry. So
probably worth
other than for biting you, Dave.
So unfortunately, I mean, I've sold myself a pup here, because the answer is I don't know very much about them at all. My knowledge really does stop pretty much when we get to the end of dinosaurs, and even the Jurassic and Cretaceous birds, I'm pretty terrible at them. There were obviously teeth were around in the earliest birds. They were lost in multiple different lineages at various different times. After that, I'm kind of running out, I'm afraid.
I mean, they just.
But at least a vague answer.
It's better than I can do. I don't know where they are. I know that, but the egg tooth.
They're in the ground mostly.
Is that? Yeah, they're not extant. They're extinct. Anyway, so let's try. Oh goodness!
No, we had a
I missed one.
We had a Teratophonius one, yeah.
And the Teratophonius one, Dave. Obviously, he's called you Dr. Hone, so that's a good start.
Yeah.
Wait till it's a professor.
Yeah.
It's gonna be a nightmare.
So after the Teratophonius bone bird, what do you think about Tyrannosaur Pax debate now? Basically, nothing has changed for me. So I was one of the referees of that paper. So that came out in Piaget, and you can see the reviewing history for most of those. You can see me and what I said about it. And I had the same comments with those authors as I've made on the podcast. In the and indeed their final published version of the paper says largely the sort of things that I've been saying, in that evidence for a group of dinosaurs being together, even if it's a very sudden, almost instantaneous event which probably killed them. In other words, they weren't just washed together or probably forced together by a drought or something like that, is some tentative evidence that they were living together. But that doesn't necessarily tell you that they hunted together. And in fact, we're going to cover this in the coming series. Actually, on more than one occasion, so I really don't want to get too far into it.
Well, but we can spoil it for them. We can spoil it because it's a
pre-spoiler. It's a pre-spoiler.
Yeah. It's a pre-spoiler. Dave talks about polar bears and whales. It's cool. Anyway.
Yeah. That's my answer to pack hunting and Tyrannosaurs. Wait till you hear about polar bears.
Oh my goodness, it's going to be cool. So let's have a go. Quincy.
Oh, there was the Imagosaurus.
Okay, I've got to find it. You distract him, Dave. I'm going to Google Imagosaurus.
Imagosaurus.
Such a good name.
Yes. So Vaginosaurus is one of the Imagosaurs, which I think we've mentioned before. So one of the really short-necked sauropod group who are within the Flagellichordata because they're close to the Diplodocus despite the small necks. And the famous one of this is Imagosaurus, these really big spines, pairs of spines along the neck. And this guy, this one, has the same thing, but they point forwards. There's immediately a massive caveat to that because that's the life reconstruction. But actually, if you look at the specimen, there's like 2 vertebrae. And the spines on those point forwards, but we don't actually know if the others point forwards. It's a reasonable hypothesis, but we don't know. When the paper came out, so I in general, when I've done, there we go. In general, when I've done any kind of science outreach and communication and all the rest of it, I always try and be polite and generous to my colleagues. But this is one occasion where they went, oh, we think it might be an anti-predator defense. And I think that's an appalling hypothesis. And I'm going to say I think that's an appalling hypothesis. Because if it was, why don't all the other sauropods have it, including the other Imagosaurs, which all have similar spines, but none of them are shaped like that? We know theropods are more than capable of biting through them. We know that necks aren't really the most vulnerable part of a sauropod. Having a neck shield is great, but your legs are exposed. And that's where your biggest muscles are. And and there's some reasonable hypothesis, there's some reasonable evidence to suggest that neck spines and things in Imagosaurus and the other Imagosaurids before this thing had come along were probably under some kind of sexual selection. So to immediately leap to an alternative hypothesis without really any evidence whatsoever, and it doesn't make a lot of sense, is not a great argument.
I can't see anything more attractive than massive spines pointing down over your loved one's face. I think it would be the best thing ever. Right, we've had some more questions. So just making sure I'm not missing anybody. I think we've got what do we know about the biology and ecology of baryonyx and
Suchomimus.
Suchomimus sounds like some sort of like evil Roman, but
crocodile mimic is the translation.
Suchomimus.
So you see
Sucho,
a lot
crocodile,
for all kinds of different crocodile things,
and then mimus as in
as a mimic.
Trapped in a box.
Just similar and yet different. So you're right. Spinosaurus gets the kind of disproportionate amount of the attention. I mean, I think going back to the Spinosaurus episode from my paper with Tom Holtz, we don't think actually that Spinosaurus is doing anything that different to the other Spinosaurids. It's probably doing something a bit different because it does look like it's got pretty short legs. The tail is a bit weird. The bone density looks a bit different. These are probably things which would help it swim a bit better than the others. But the fundamental head shape, neck build, arm build are basically identical between them. And the diet data that we have for those, baryonyx with fish in the stomach, but also baby iguanodon bones, head shape on both of them functions very similar. There's several papers by Andrew Cuff and Emily Rayfield exploring this. So the heads in baryonyx and Spinosaurus are functioning fundamentally identically. That suggests they're doing the same thing in the same way. And therefore, I think all of these things are this kind of heron mimic or bear mimic or quite whatever you want to call it, of something that's grabbing stuff that's feeding, grabbing stuff in the water, but also grabbing stuff on land and, doing a bit of both.
Being like perfect seagull, heron kind of modern bird predator that you see now, really, because that's what they're...
Yeah, I mean, obviously herons and storks and things can fly, but, some of them, particularly, things like marabou storks, the big ones, don't do that very much. It's mostly as an escape response. And when you're Spinosaurus, you don't need to escape from anything. And similar, Suchomimus and baryonyx, these are big carnivores in their environments. Again, think kind of bear-like thing.
I mean, it's scarier than a bear, Dave.
Well, right, but but even there were comparably sized theropods to baryonyx, but big carnivores don't normally get into big fights with other carnivores all the time. It's a terrible idea, particularly things that are fundamentally feeding in a different system, and you're probably not really in competition with them. So
I will kill
it's
the
pretty
thing
safe.
which has the most apparent ability to kill meat.
Kill meat. Well, right.
Exactly,
It's a poor choice, right?
Yeah.
So yeah, I think the Spinosaurs as a whole are much of a muchness, and we're talking in the grand scheme of things, subtleties about their different ecologies. I'm sure they were different, but again, in the way that various storks and herons are different to each other, but they're broadly doing the same stuff.
Really shy. One of them is really shy, and the other one's very gregarious.
Yes.
As a species, that's how it's done. So we've got an amazing name. Now, at their peak, were dinosaurs as or more diverse than mammals today in terms of filling niches? Can I answer this one, please? Please, can I answer this one, please? I sort of know the answer to this one, which is that there was actually less biodiversity in terms of dinosaurs compared to today because they grew. So as the dinosaurs started, they're all in eggs about this big, maximum maybe that big, longer thin ones. Due to like shell size, etc. And what happened was that as the dinosaur grew, it filled in all the niches. So you could have, for example, a rabbit and a sheep getting along, filling very different niches in the environment. But if you're the same species, if a rabbit turned into a sheep, which then turned into a cow, which then turned into an elephant, which then turned into 10 elephants, they're all going through different parts of the of the system without so all the niches are being filled by one species. How was that, Dave? Was that good?
Basically spot on. I mean, the only thing I'll add to that is, so one of the things I was going to say for the new papers is this is something that lots of paleontologists, including me, have said for a while. And I mean, in the scientific literature as well, but without really a lot of evidence. It seems kind of self-evidently true that it must be the case unless there's something weird going on, but demonstrating it's actually been quite hard. And then we've had basically 2 papers on this in the last couple of months. One by Schroeder et al., who did this for big theropods generally, and then Tom Holtz, who's coming back again, who has a paper that's in press and announced, but the paper hasn't quite appeared yet, but it's coming any day, doing it just with the Tyrannosaurs, but both having done some actual analyses and comparisons and showing for the carnivores, at least, that this appears to be genuinely true. So we said this a lot and we've thought it, but now we've got some fairly solid evidence to back it up that this is what's happening.
Forget my rabbit sheep analysis and go for more sort of like stoats, house cats.
Right, but it's probably also true of the herbivores, but there's no reason to think it isn't. But that's the data set that they've used. So,
okay, we got a hot tip here. Should we be going to Italy to look for sauropod bones? There's a number of sauropod tracks close to where Renato is from. Have you heard of them? And would it be possible? Basically, the profitable place to find bones. Is it a good idea to go looking for bones where you find footprints?
So generally, no. There are a few real exceptions to this, but in general, the kind of sediments that preserve footprints don't preserve body fossils or bones and teeth. There are a couple of exceptions. Protoceratops is one of them. So there's a Protoceratops from Mongolia where there is a skeleton with 2 or 3 tracks preserved with it, which is really, really cool. There are some other places where trackways are pretty close to fossils, i.e., I mean, obviously, you've clearly got rocks of about the right age. Oh, well, I can do...
Oh, you can do better than that, can't you?
Slightly better than that, because I got this one. And in fact, going back to the previous question, so this is about a 2/3, maybe even half-grown Protoceratops skull, so they get sizably bigger than this. And here is a 3D print I had done of one of the smallest known hatchlings. So you can see, it basically fits in the eye socket, and this one's only half-grown.
Oh,
so that's the kind of size discrepancy that we're talking about for Protoceratops.
It's crazy.
So going back to the footprints, in general, if you're out in an area of a few square kilometers and here's footprints coming out of the hillside or in a bed, it's not a good place to look for bones. On the flip side, as I say, at least you've got rocks of clearly the right age if you've got dinosaurs flopping around, and there were dinosaurs there, so you've got some terrestrial sediments. You never know your luck. But if I had to guess, I'd say no. It's more often than not, it's not going to be a good spot to get to head to.
Basically, you can say that about the majority of the planet. More often than not, the place where you're looking isn't the right place, except when it is, and then it's amazing. So now let's have a go, because I don't want to. I want to make sure some people get in. So we got to hone. I like that. Good on you, Gutter. Have you ever watched The Land Before Time sequels? They were the subject of a lot of my childhood daydreams, mainly because one of them had aliens. So it's a very important dinosaur question.
I haven't seen any of the sequels, and actually, despite being a really avid dinosaur film lover, one of the first big events I ever did for SciComm's outreach, whatever you want to call it, was on dinosaurs in film, and I did a whole day event at the London Cinema. I've only actually seen the original Land Before Time last year or two, because I didn't have it, and it's the kind of thing that's never on TV. So I had to wait until there was a cheap DVD knocking around, and I bought it for like £3 or something. Yeah, it was all right, but I haven't seen any of the sequels. I think everyone loves it as a great kids film, and it's right.
I believe that was one I watched in Australia on VHS. The Land Before Time. It's one of those ones. Now, this one I want to know the question. I don't think it's been asked by anybody so far, and I think the answer is going to be we just don't know. But were there any venomous or poisonous dinosaurs? How good a question is that? Imagine you get away from your T-Rex, but you scratched yourself on its fang tooth, which you probably no, it was not going, and you die from the bite.
Yes. So, and until relatively recently, like the 80s, you'll see poison and venom used almost synonymously, and fairly recently, in the grand scheme of things, there's been a move to make them distinct. Venomous. So it's worth classifying that. So go on then.
I know. If you're venomous, it means when you bite people, you poison them with your venom, and then they die or get ill from that. Or if you eat the dinosaur's flesh, and you die from eating the dinosaur's flesh, that's poisonous, you see. So venomous means you get bitten, and poisonous means you bite.
Yes. Yeah. So there's lots of venomous snakes. There's very few poisonous snakes. So poison for a dinosaur, I don't know how we'd ever know. I guess in theory, some kind of chemical signature could be retained, but boy, I doubt it, because usually these things are very weird molecules, and that certainly a lot of venom breaks down very quickly. So it's not the kind of thing that's likely to preserve at the best of times.
I have a question.
Yes.
I have a question. Are there any venomous birds?
There's no venomous birds. I think there are a couple which are poisonous. But whether they're poisonous,
well, chicken if you don't cook it thoroughly.
Well, right. So that's not. So whether they're poisonous in the sense that they have evolved the storage of nasty compounds to stop things eating them, or whether they happen to coincidentally have toxins in them for us, is another matter entirely. So I know some of the snake venom literature. The reason snakes are often, apart from obvious things like rattlesnakes, things with dirty, great fangs in them, a lot of the reason that some snakes are identified as being venomous is they bite someone and someone has a reaction to them, which, of course, for snakes that eat, say, frogs or fish or insects, their venom is almost certainly not well suited to getting a good reaction out of big mammals. And therefore, I know there's certainly a suspicion, at least, that there's a bunch of snakes out there which are extremely venomous for the things that they're eating, but as far as humans are aware, it bit me and it drew blood, but nothing happened, so there's probably no venom there, because again, there's an awful lot of snakes and only so many biologists, and everything takes time.
I'm disappointed by the lack of scientists who aren't going around, testing snakes.
But for every single thing they could possibly feed, and venom doesn't store well, and getting it out of, bear in mind some of these snakes are like this big.
Yeah. But I've seen them milking snakes. It's amazing when they.
So there's a guy. There's a guy called James Asher who was out in Mombasa who I ran into years and years ago when I was in Kenya, and it turned out he's quite well known among some people as a biologist who went into this. And by the way, we'll get back to answering your question in a minute. We're obviously just distracted. And yeah, he ran this little snake farm, and this guy had this, like, I want to say like 15 or 20 of these cages he'd made, which were about 2 meters cubed, and in every one of them there was anything between 2 and about 10 black mambas. And because he was milking them for their venom, they'd massively like engorged venom glands. And if anyone knows mambas, they're really quite slim snakes in the grand scheme of things. And these things, their venom, the proglotid glands, their venom glands, which are basically here in the snake, were so big that basically you had the bulge for the head, and then the bulge for the venom glands, which was bigger than the head, and then the rest of the snake. And I was there with a couple of friends, and he showed me. He like took the lid off, shoved his arm into this vat of 4 or 5 snakes, which are potentially at least lethally venomous at the best of times, and now all have these giant swollen venom glands. And pulls it out, and goes, "Look, here it is."
There's these are mambas. I don't think this is a juvenile.
But which was slightly terrifying. But anyway,
sort of see there where the glands sort of.
Well, that's just a bit of flattening. So, a lot of snakes do this kind of pseudo cobra thing where they flatten a bit, but they don't have the hood. So poisonous dinosaurs, don't know, almost certainly can't know. Venomous dinosaurs. So aside from the Dilophosaurus spitting venom in Jurassic Park, which was an entire fiction, there is one dinosaur which was once suggested to be venomous, and it was, I think it was Sinornithosaurus. There's Sinornithosaurus and Sinornithoides, and I often mix them up, but I think it was Sinornithosaurus.
You say Sinornithosaurus. I say
Sinornithoides. Well, and they're both.
I'm not spelling any of this, guys.
One's a Troodontid and one's a Dromaeosaur. They're both about the same size. They're both from China, and they're both held in the same museum. So I always mix them up. We'll call it Sinornithosaurus, the Dromaeosaur. So half-ish the size of Velociraptor. So there's my Velociraptor skull. So about half that size. So head only about this long. Talking an animal meter and a bit long total, including the tail. And yeah, there was a paper published basically arguing that this thing was venomous for 2 main reasons. First of all, this kind of slight socket in the side of the skull was supposed to be a potential house for a venom gland, and then secondly, really long teeth with a slight groove in them for venom delivery. The slight socket in the skull, it's a crushed skull. Whether it's there or not is truly hard to say, and all dromaeosaurs, indeed all dinosaurs, have a very complex arrangement of pockets and cavities in the side of the skull. What makes one of them particularly special, different from the others? I mean, it's a shot. I mean, maybe, but yeah. And then the really long... and there's the critical thing. So really long... and now I've got the wrong skull out. So really long... Well, now it's going to get wibbly because I've put the computer on now the one thing which I need to show people. And so, of course, I need to do this to open the box and get it out. So, oh yes, because it's bouncing.
Don't concentrate, Dave. Everybody,
so long
when he wiggles about, he breaks up a bit. Just so you know, he's still there, but we'll wait for him to settle down. But there we go. Dave Hone will be still talking to himself right now whilst he's frozen. Oh, here we go. Dave, when you can hear me, settle down and sit. There we go. Are you back?
I am settled down. Yes.
Good.
I'm still
there we go. You're back with us. Just so you know, Dave.
Rifling through my drawers.
What was that? Was that a sea cucumber? No. Okay. Fair enough. That was that. Oh, I know. Tyrannosaur collarbone.
Yeah.
There you go. It's that.
Yes. So
you can see why I won so many beauty contests as a child. Look.
So long teeth with a groove in them. So here is a very fragmentary tyrannosaur maxilla. And as you can see, there's a long tooth here and a really long tooth here. And that really long tooth, there's a little bit of a depression up here, but on the back side, you can see this very clear and obvious groove in them. And that's because this tooth is in the process of falling out. And what would sit here normally is the next tooth that's growing. And this is a really common thing that teeth of theropods, when the skull started to rot, the teeth start to come out and they look much longer than they actually are. And on some of them, you then see this depression in the root for the sequential tooth. So Stan the T-Rex, who got sold last year, but there's casts of Stan everywhere. Stan has absurdly long teeth because all of Stan's teeth are falling out. And obviously they didn't sit them back, but people often take that as being correct. And the other thing you can see on Stan quite clearly, and you can just about see it on this one, again, this is a cast, but you can see about here, there's a slight change in texture. I know it's not going to show up very well.
It's showing.
So about here, but because this is obviously a monochrome cast, in the real thing, you'd see the color change because that's where the enamel is stopping and the underlying dentine is going. So this is Spinosaurus. You take one look at it and you go, those really long teeth are falling out and those grooves are the sockets for replacement teeth. These are not long venom delivery teeth. And yeah,
it ruins everything.
Yeah, and it's one of those. I think it's one of those examples, to be honest, where like the paper came out and a lot of people were like, "What?" And I was in. So this specimen is held in the IVPP in China, the Institute for Vertebrate Paleontology and Paleoanthropology, where I was based for a number of years. And that specimen was like right there in the lab, and so I went and got it like the day the paper came out. And I was sat down with this thing, going over the new description and the discussion, and the specimen going, I can't see that. I can't see that. No, this is the same as that other specimen. And you say it's different, and it's not. It's the same. And I started writing a response paper and spoke to a couple of other people who, of course, the background chat on Facebook and its equivalents back then, kind of going, oh, we should say something about this. And within like 2 or 3 weeks, someone had already published a response going, no, it's not venomous. So stop bothering because someone had already done it. And that idea, but it's a classic example. I know that wasn't the original question, but it's one that's like, this thing appeared, made a bit of a splash in the media, though I think the paleontological community was extremely skeptical. It got shot down pretty hard and very fast. And yet you still see people going, oh yeah, dinosaurs are venomous. There was that one they found in China. Which is annoying, but that's how a lot of this stuff goes, unfortunately.
This little question came up, and that is because I'm useless. We do have merch, that's the thing. But if you go to terriblelizards.co.uk, there should be links to the Redbubble, which is where you can pick up like mugs and like masks and t-shirts and things, which we're also not wearing because we're rubbish. We do have them.
I meant to put my t-shirt on and forgot.
That's the thing. We do this because we love it, and it isn't a massive profit money making thing. However, if you do want to support us, Patreon, please, it does make a difference because we're both very busy people. Anyway, this is a good question which goes right off. How long does one tooth last? You got those Tyrannosaurs, their teeth falling out. How long is one of them going to last, do you reckon?
It varies a lot. So I think most of this stuff's been done on theropods, and certainly that's the bit of the literature that I've read. Anything from about 3 to 9 months or so, give or take. So some of them pretty brief, some of them pretty long. In fact, there was a paper by someone whose name I've forgotten, for which I apologize if by any chance you're listening, and Oliver Rauhut, and I remember Ollie Rauhut because I did my postdoc with him years ago, looking at Spinosaurus teeth actually recently. It was highly relevant. It came out just in time for us to include it in our paper, showing that Spinosaurus, it looks like, has a faster turnaround of teeth than other theropods do. Now, that was really interesting because there'd been another paper published at the back end of 2020 saying part of the evidence for Spinosaurus being a super aquatic-y thing is because look at all these Spinosaur teeth we keep finding in water. But if they're shedding teeth far more often than other dinosaurs, then you will find more teeth of them. Yeah. So as usual with these things, it's all complicated and things, one thing pushes one way, but there's something that pushes back the other way. In general, bigger dinosaurs, their teeth last longer.
Well, they're bigger teeth, so it's stronger, presumably. I mean, why do they fall out? Is it just a natural? Is it like a shark, or do they go wobbly like ours, or what's the mechanism? Do they just get pushed out by the new tooth?
So what's happening? So what you mostly find? Aha, here we go. Yeah, another thing.
Oh, here we go. Please don't move. Please don't move things about.
Yeah, no, this is the easy one. So what you mostly find in the field when it comes to, so here's a Tyrannosaur tooth. This is an actual real fossil this time.
Oh, cool. Not a cast.
No, so this one is from Alberta. Before anyone says, you are not normally allowed to have fossils from Alberta.
Yes, we're not normally allowed to have fossils from Alberta.
As proof, there's my Royal Tyrrell Museum specimen number. It is on loan to me. It would normally be in the office. It's at home right now because I've been doing outreach stuff online. So I do have an official loan documentation for this. But when you find loads of Tyrannosaur fossils out in the field, loads of Tyrannosaur teeth. I mean, and theropods generally, but obviously where I go, a lot of Tyrannosaurs. And they're usually like that. It's the end of the tooth. It's just the crown. There's no root at all. And these are mostly shed teeth. So what's going on when you've got a whole tooth? So there's our whole T-Rex tooth. And there's your groove for the next one. So that is sitting in the mouth. There's the crown. The root is sitting, inside the bone. And your next tooth is growing somewhat inside that groove. And as that second replacement tooth is getting bigger and bigger and bigger and gets close to being done, the root is basically absorbed. It dissolves away. So we talked about this before. Bone is constantly growing and breaking down all the time, but you can accelerate and decelerate some bits of that depending on quite what's happening. So that all gets resorbed. And then this bit is then very, very loose. And it's got another tooth growing out behind it, and so it will probably just fall out. So we talk about
just like being a kid. Then when your teeth go through and you get wobbly tooth, that's same sort of thing.
And so every so often we find what are called shed teeth. You will find things. So there's a sauropod from Thailand that has this. So there's bones with bite marks on them, and the tooth has fallen out, presumably as part of that feeding.
I'm just going to put this question up because you can literally just show him.
Yeah. So this is
big.
So this is Stan. This is Stan's biggest tooth or second biggest tooth. Stan is obviously very sizable, but far from the largest T-Rex. So they do get bigger than this. But that is the crown. That is the bit that would bite into things, and that's what 15, 17 centimeters. They get a bit bigger than that, a big specimen like Sue or Scotty, 2022 maybe.
I've got I'm like less than a centimeter, I reckon. Maybe a centimeter.
Yeah, we don't have particularly big gnashes.
No. Sad.
So yeah, so those teeth fall out, and then in one particularly nice case, so the pterosaur I named a couple of years ago now.
Not a dinosaur, Dave.
But that's where we're going. So the pterosaur I named a couple of years ago, Cryodracon, this big Ashdarkid from Canada. That was first described back in the 80s, I want to say. There was a paper in 1993 because the tibia of that, so the big shin bone, has a theropod tooth stuck in it. It's like physically jammed in, and then the end has no crown, and so that absolutely looks like a shed tooth from feeding. It wasn't just found next to it; it's stuck in the bone.
I think we've got time for one more question, and this would be a really good one to follow on from that. It might be a silly question, not a silly question, Paul, and there are no silly questions, because they probably got killed off quickly, but is there evidence of dinosaurs lasting quite a while with an injury or disability? And I think that, obviously that, is if something's, all I want to talk about is shed teeth in bone and how long they last there, because I think we covered it before, haven't we? Am I misremembering this?
The problem you and I had is did we talk about that 6 weeks ago and it hasn't come up in the show yet?
No, this is older.
We're in this horrible loop.
I think this is us talking about dinosaurs biting each other and therefore having injuries which they're living with because the bone regrows.
Yeah, so loads of tyrannosaurs have injuries on them, particularly on the faces. They're relatively minor in the grand scheme of things, but there are some nastier ones. There's a Tyrannosaur I described from Canada yet again. So if we obviously not a Tyrannosaur or Velociraptor, but it's the skull I've got to hand. If we turn it around and look at the back, you see you've got these pair of big flanges at the top, and one of this Tyrannosaur had one of those basically bitten off and snapped, but it was healed around the edge. So that wasn't a break, that was something which had been removed, and with big holes through it that were Tyrannosaur tooth shaped. So about the only thing that could do that really is another Tyrannosaur biting on the back of its head and literally breaking part of its skull off. And it healed, so it's presumably fine, or at least fine for a while. We've got all kinds of things with various injuries on the bones. Also at the same Tyrrell Museum in Alberta, it's this beautiful Tyrannosaur on the wall, this really famous one, the head back and tail over the top. And there's a really obvious giant bulge halfway down the shin, which is a classic sign of an infection on the bone that's then rehealed, or a break that's then rehealed and kind of swollen up, just as it does with us. There's several herbivorous dinosaurs with T-Rex teeth broken off in the bones and the bones healed around them. There's a T-Rex which has allegedly most of the tail bitten off, and so it only had like a third of a tail or less. I think it's a little bit controversial, but I think most people are fairly happy.
Was it not autotomy? No.
No, it's not autotomy.
Autotomy. There we go.
No, because it would have to be because it's got a really nasty, giant, swollen, pathological end to it. And the inference was that it was basically bitten off. And of course, the rest of it being missing doesn't mean that there wasn't something else beyond that. Maybe cartilaginous, maybe it just didn't fossilize. But certainly, it's a hell of a mess to have. And I don't think it's unreasonable that the tail was fundamentally missing. And there's a bunch of other. There's one with a really kinked tail where the tail's clearly just broken and then healed up, so it just goes at right angles. Not a Tyrannosaur, a sauropod, I want to say, but
a very sauropod.
Yeah, I mean, loads and loads and loads of things with injuries. It's really common for them to have injuries, as you might expect actually from a natural population. Like really serious things, like a completely missing leg. The best thing I can think of is there's a hadrosaur. Well, no, there's a hadrosaur with the radius and ulna, so the two main bones of the lower arm, and they're basically completely fused together. Ooh. So they basically shattered, I think, for want of a better word, and then fused back when they healed, but in an awful wonky shape. It's hard not to imagine that's a pretty crippling injury. We do think dinosaurs healed pretty fast, so it's not like that took years to get better. It could have been weeks, whereas for us it would be months. But still, that dinosaur was still around for a good long time, probably only able to walk on 3 legs.
Goodness. Hopalopodon.
But you said right. So, but there's videos online and photos. There's 3-legged deer are quite common. Hunters come across them fairly regularly, and obviously that's a horrible injury, and they're lucky they haven't got gangrene or something else, and their legs are very spindly, which might well help with that kind of thing. But still, it's not, it's not millions to one that an animal just dies. If it's broken its leg, it's millions to one that it survived. It happens.
Right now, I think we've still got loads of questions.
I was going to say, our half hour's going on for 50 minutes.
Our half hour's gone for 50 minutes. So what I will do is I will just encourage you guys to go to our website. Look, isn't it lovely? It's terriblelizards.co.uk. You can catch up with all of the episodes there, or you can visit our Patreon. You can go to, and this will probably open in a new, no, it won't. So you can go to our Redbubble there and you can buy yourself a t-shirt if you so wish, or a phone cover thing, or a mug, or I got the mugs. It's really nice.
A friend of mine bought the cushion cover.
It's really, there we go. You see, people are buying them, not very many, but we do have them if you want them. It's all here. And if you want to support us on Patreon, that's opened in a new window. So I'll just go over here and do it here, and there we go. So please do. It does matter a lot to us. You get see. Oh, look how handsome we are. We're beautiful.
You look better than me at that
and you get to message us and all of that and ask us everything, and you get bonus extended episode with Adam Rutherford. I mean, who wouldn't want?
Is that when we just talked about Star Wars for 25 minutes?
No, that's the bit that made the episode.
Oh, yeah, we talked about well, because we got into a patasaur vertebrae forming starships.
Oh, brilliant! Well, anyway, this thing. We are coming out. An episode will drop tomorrow. We'll drop it tomorrow, and it'll go out all the Wednesdays and that sort of thing. If you want to get involved with us, please. We check the Facebook page. We're on Twitter. We do all the things. It's nice to interact with you guys. And apparently, we've been looking after your children during lockdown. So. You owe us, basically, is what we're saying. No, you don't. But yeah, up in this series, what we got, Dave, we've got Tyrannosaurs, but not
all the other Tyrannosaurs. We got Scansoriopterigids, which you still can't say.
I can say Scansoriopterigids.
Oh yes, you can now.
Scansoriopterigids.
We've got them. We've got which is the largest dinosaur.
Yeah, not witches, because that's Harry Potter. That's different. We do actually have that one, don't we? We've got the social groups as well, so we talk about that. So we also have possibly the most boring title. It's called Dinosaur Dinosaur Papers, which is all about actually how the science works and how you actually get a paper about dinosaurs into the science literature, which sounds really dull and isn't. So
I'm glad you finished that, because I really wanted to put that in and you were less keen. So hopefully it will not be.
And also we obviously thank you so for saying hello and yay. We're going to go away now and think about what we've done. And but yes, please do share the podcast with friends. Like we say, it is suitable for short people. I take all of his blaspheming out. So yes, all references are scientific. We're going to say rawr.